Today we're going to be talking about simple probability. So this is going to be your 10.2 notes. I've got a note sheet handout for you. So if you've got a printer at home, great, print it out. It'll make your life a little bit easier. If not, just copy it on paper. So with simple probability, we're going to start talking about the definition of probability. So we kind of started working with some experimenting yesterday. We learned that if we flip a coin, there's a 50-50 chance of getting heads or getting tails, and things like that. So we're just going to go a little bit more in depth with that, and we're actually going to be taking notes over that theoretical and experimental probability that we were kind of mentioning yesterday. So let's go ahead and get started. So the probability of an event is a number that measures the likelihood that the event will occur. Probabilities range between 0 and 1, including 0 and 1. The diagram relates the likelihoods of above the diagram and the probabilities which are below the diagram. So if you're taking notes at home, I would copy down the definition, which is right there. And then I would 100% copy down this section here. So if the event is impossible, so like if I'm flipping a coin and I say, I'm going to flip an arm, that is impossible. There's not an arm. It's either heads or tails. So there is a 0 chance that that's going to happen, a 0 probability. That 0 probability as a fraction or as a decimal is going to just be 0. We could also write our percentages as a actual decimal. As an actual decimal, it's still 0. There we go. And then we could also write it as a percentage. So we would also say 0%. I'm going to zoom in just a little bit and then clean this up. So we just did impossible. Let's go on the other end of the spectrum to certain. So if I'm flipping a coin and I say, I'm going to either flip a heads or a tails, that is certain. I'm either going to flip a heads or a tails. That is a 100% chance of that happening. So as a fraction, that is 1. As a decimal, that is also 1. And as a percent, that is a 100% chance. In the middle, we have equally likely to happen or not happen. So with this, if I'm flipping a coin, for example, again, if I say, I'm going to flip a tails, that's a 50-50 chance. So that's as equally likely to happen as not. As a fraction, that's 1/2. As a decimal, that's 0.5. I find that by taking 1 divided by 2. And then as a percentage, it's a 50% chance because it's 50-50 shot. And so those 3 numbers, impossible, certain, and equally likely to happen or not to happen, are set in stone. So if it's impossible, has to be 0%. If it's equally likely to happen, has to be 50%. Same thing with certain, has to be 100%. This unlikely and likely are a range of numbers. So it goes from as close as you can get to impossible all the way to as close as you can get to equally likely. It's that whole entire range. And this is the same thing. It's that whole entire range. So if I tell you that there's a 1% chance of it happening, it's not impossible, it's just unlikely. If I tell you it's 99% possible, it's not certain because it's not 100, but it is likely. So the middle range is what we're going for here. So this is going to be 1/4 of the way, because if we count 1, 2, 3, 4. As a decimal, 1/4 is going to be 0.25, and as a percentage, that's 25%. Same situation with likely, 3/4 of the way, 1, 2, 3. And as a decimal, that is 0.75. As a percent, that is 75%. So for this diagram here, as long as you understand and know the impossible, equally likely, and certain. Anything in between is either going to be unlikely or likely, depending on which side of the equally likely it's on. If you have any questions over this, make sure you ask, because this is an important concept in 7th grade. So let's move on. Next, we're going to talk about finding the probability of an event. We talked about this a little bit yesterday. So when all possible outcomes are equally likely, the probability of an event is a ratio, remember ratio means fraction, of the number of favorable outcomes to the number of possible outcomes. The probability of an event is written as P and then in the parentheses event. And so this is the formula. This is the important thing to write down in your notes. So we're going to have the probability of some event. So if we wanted to roll a 4 on a dice, we would replace that event with a 4. If we wanted to roll evens, we would replace that event with the word even. Even. And then the number of favorable outcomes over the number of possible outcomes. So the number of possible outcomes means the total number of possible outcomes. And the number of favorable outcomes are the ones that we want. So ask yourself what numbers would make us happy. So depending on what your event is, that is going to determine how many possible outcomes or how many favorable outcomes there are, because that's going to be how much we want. So we talked about this a little bit. I did it up here in this little diagram. So probability can be written 3 different ways. The first way is going to be as a fraction. The second way as a decimal. And the last way as a percent. And so I don't care which way you write it in. I'm going to be giving it to you in all 3 ways eventually. So just make sure that you know that it's all 3 ways can be written as the probability. So a fraction, a decimal, and a percent all can be written as the probability. So I don't really care how you write it unless I tell you specifically that's how I want it written. So let's try some practice problems. So we're going to describe the likelihood of each event. So we're going to think back to that diagram, that colorful one up here, and we're going to describe the likelihood of the event. So if there's a 75% chance of rain, where does it fall on the diagram? So let's look back up at that chart. Since it is a 75% chance, I don't have the notes anymore because I erased them, but what are you doing, bud? Go back down. You can look at this and I know that 75% fell on this line right here, which is a likely event. So you're going to go ahead. Oh my gosh, this is so slow today. Scroll down, please. Okay, all at once. So for that first one, A, you're going to say that that is a likely event. We're going to do the same thing for B, but this time it says a 35% chance. So 35% chance wasn't one of the things we looked at. We looked at 0, we looked at 25, and then we looked at 50. So if we were to place 30, what was it, 35, 33, somewhere in there, 35. If we're going to place 35 somewhere on this number line, it's going to go right about here. And remember, we talked about unlikely being a range. So it goes from just above impossible to just below equally likely. So since it is not 0 and it is not 50, it is going to be unlikely. So for B, we're going to write unlikely. C says tomorrow you will be 11% or 11 feet tall. What's the probability that you're going to grow up to be 11 feet tall by tomorrow? Hopefully you said that it is a 0% chance because nobody's 11 feet tall. So that's going to be impossible. Our last one is you will have math homework this week. You actually have math homework tonight. So what's the probability that you're going to have math homework this week? You can be optimistic and say that it's likely, but it's actually going to be certain. So that's going to be 100% chance because you do have it tonight. So it is a certain probability. So you're going to go ahead and write certain next to, I think that was letter D. Oh my gosh. Example number 2, we're flipping a coin. So I want you to try to do these two on your own. So remember, our format is probability of heads and probability of tails. So try those two on your own. So for this one, we're looking at the, let me go back up to it, the probability of an event, because it says P of the event. So we're going to list the number of favorable outcomes over the number of possible outcomes. So the probability of getting heads is 1 out of 2 possible choices, which is going to be 50%, or you could say 0.5. So any of those 3 answers would be correct. And it's actually the same exact thing for tails, 1/2, and so on and so forth. Yesterday, when we looked at flipping a coin, you actually flipped it 20 times. I'm going to guess that you probably didn't get 10 heads and 10 tails, because this is the theoretical probability. So this right here is our theoretical, I'm running out of room, theoretical probability. This right here, what we did yesterday, was our experimental probability. So the theoretical is what we think is going to happen. It's like what's going to probably happen if it were a perfect world. But we don't live in a perfect world. So yesterday's experiment was experimental probability because it's what happens in the real world. Let's move on to example 3. So this is for rolling a die. So I've got a bunch of different outcomes listed here. I'll do the first one with you, and then I'm going to have you do the rest of them on your own. So if we're rolling a D6 die, like a normal regular die with 6 sides, what's the probability of rolling 1? Well, that's only one side out of 6 possible sides. So it's going to be a 1 out of 6 chance. We're going to go to our calculator, and we're going to figure out what that fraction is as a decimal, because I like to write it as percents. You could leave it as that 1/6, but as a percent, that is going to be a 16, almost a 17% chance. So we'll just call it a 17 rounding up. And so when it's written as a percent, I think it's a lot easier to see whether it is unlikely, likely, equally likely, whatever it is. So I like changing it to be percentages because I understand that number a lot better than I understand a fraction. So I would recommend that you do that as well to be able to better understand that unlikely versus likely outcome. So you're doing the exact same thing I did to problem A to the rest of them. So you've got the probability of getting 1, 2, 3, 4, 5, 6, an even number, the number 7, a number less than 5, and the probability of a number less than 9. So go ahead, pause the video, try out these problems, and then check your answers with me after. Hopefully that didn't take you too long because there was a lot of repeats. So the numbers 1 through 6, or A through F, you should have gotten 1/6 or 17%, because we're looking at one side of the die for each one of those. Even, there's going to be 3 even numbers. Those are 2, 4, and 6. So there's 3 favorable outcomes over 6 possible outcomes. That's going to be a 50% chance. The probability of rolling a 7 is a 0% chance because there's not a 7 on the die. So it's going to be a 0% chance. Moving over to I, a number less than 5. Well, there's 1, 2, 3, and 4. So there's 4 numbers out of 6 total. Divide that in your calculator, and you get 66.666 forever and ever. So we're going to round that up to be 67%. And then our last one is a number less than 9. Well, 1 through 6 are all less than 9, so it's 6 out of 6, which is going to be a 100% chance. So let's move on to number 4. So there are 12 blue marbles, 4 green marbles, and 14 red marbles in a bag. If you reach in and grab one marble, find the probability of each of them. So if we're finding the probability of drawing a red marble, think about how many red marbles are going to be in this bag. There's going to be 14 over the total number. To be able to figure that one out, we have to add 12, 4, and 14 together. When we do that, we get, let's see, 1, 2, 30. Yeah, 30. So it is 14 out of 30. If we wanted to make that into a percentage, because percentages are a little bit easier to understand, we're going to pull up our calculator and we're going to type 14 out of 30 into our calculator, and it's a 47% chance, which makes sense because if it was 15 out of 30, it would be a 50% chance because 15 is half of 30. So it makes sense that it's just a little bit less than 50%. Our next one says the probability of not red. So not red is going to be either blue or green. So to be able to figure out our number of favorable outcomes, we're going to add those two numbers together. 12 plus 4 gives us 16 out of 30. Since this one was 3 less, I'm going to guess that this one is 3 more percent over 50. So I'm going to guess that it's going to be 53. So let's test my theory. Where is the calculator? I'm just going to type it. Calculator. 16 divided by 30 is 53%, just like we hypothesized. So let's go ahead and write that down, 53%. So I want you to try these next two problems on your own. Find the probability of blue or green, find the probability of getting yellow, and find the probability of getting not yellow. Pause the video and try that out. And here's your 3 answers. So saying the probability of blue or green is the same thing as saying the probability of not red. So those are actually the same answers. The probability of yellow, we don't have any yellow marbles, so it is a 0 out of 30 or a 0% chance. The probability of not yellow is everything else. So blue, green, and red are all not yellow, so it's 30 out of 30, which is 100%. And these are all theoretical probabilities. If you went and you had a bag full of marbles that had 12 blue, 4 green, and 14 red, do you really think that you would grab, I can't remember what it was, 47% of the time red? Probably not. But that is, in theory, what should happen. You actually might grab 4 green marbles in a row. Who knows? Because it is a weird world out there. So let's talk about that theoretical versus experimental and actually put a definition to them. So the definitions that I like to use, and you can come up with your own, so you have a pretty good understanding of this now. I'm just going to say the words that I use. So for theoretical probability, it's what should happen. And that's if it's a perfect world. Experimental probability is what happens when you test it. And so it's like drawing the marbles out of the bag. It's what happens in the real world when you're physically doing it. And in a story problem, the experimental probability might come as Johnny is pulling marbles out of a bag, and he pulls 5 marbles out of the bag, and they were all green. That would still be experimental probability, even though you're not doing it, it's somebody doing it. So this is a person doing it, and this is what should happen in a perfect world. If you have any questions over this lesson, please let me know, but that is the end of it. So I will talk to you later. Bye.